In this video, we are trying to understand how to express trigonometric ratios like cos, sine and tan in terms of any one of the trigonometric functions. So in the first one, we will try to express the other trigonometric functions based on sine. In the second one, we'll try to do it using cot. And in the third one, we'll try to do it using secant. So let's start with the first one. So the information given to us is if A is a triangle, is an angle in the triangle, then we have to express cos, tan and secant in terms of sine. So let's draw a representation of this. So it's a right angle triangle. So let's mark this as 90 degrees and let's consider this to be A. We know that cos square A plus sine square A is equal to 1. So this is a trigonometric identity we learnt in the previous videos. So cos square A would be equal to 1 minus sine square A. Now cos A would be equal to plus or minus square root of 1 minus sine square A. Now we found what would be cos in terms of sine A values. But here we have two choices, positive or negative. Here we will go with positive because in a triangle there cannot be negative angles. So that is the reason cos A is equal to positive value of the square root of 1 minus sine square A is the correct representation when the angle A is in a triangle. Now let's try to represent secant A. So secant A is nothing but 1 by cos A. Now we already know the value of cos A from the previous solution. So we'll write secant A is 1 by square root of 1 minus sine square A. So this is simple. Now let's address tan A. So what is the definition of tan A? It is sine A by cos A. So sine A would remain the same because our target is to represent everything on sine. Then cos A is nothing but square root of 1 minus sine square A. So this is how we can represent different trigonometric identities based on one trigonometric identity. Now let's solve the second problem. So here we have to express sine, secant and tan in terms of cot when A is an angle in the triangle. Now we know another trigonometric identity which is 1 plus cot square A is cosecant square A. So we can change this to 1 plus cot square A is equal to 1 by sine square A. So sine square A would be equal to 1 by 1 plus cot square A. Now again, we will only retain the positive value of the square root because A is an angle in the triangle and it cannot be negative. So sine A would be equal to 1 by square root of 1 plus cot square A. Now let's try to address the second part, which is finding out what is secant of A. So how do we do it? We know that 1 plus tan square A is equal to secant square A. So this is one of the identities. So this can be written as 1 plus tan square A is equal to 1 by cos square A. Oh, we don't need this because we need secant, right? So what we can do is we can change this to 1 plus 1 by cot square A is equal to secant square A. Correct? So this will change to secant square A is equal to cot square A plus 1 divided by cot square A. So if you take the common denominator for 1 plus 1 1 by cot square A, we would get this. Now we need only the positive value again. So, pardon me. So this will be secant A is equal to square root of 1 plus cot square A divided by cot square A. So we can actually solve the square root of cot square in the denominator. So we will have 1 plus cot square A divided by square root of 1 plus cot square A divided by cot A. So that is the value of secant A. Now, what is the last one we have to find? We need tan, correct? So how do we represent tan in terms of cot? It is nothing, it's very easy. So tan A is equal to 1 by cot A, right? So cot A is equal to 1 by tan. So that's it. It's just an inverse definition that we have to do. Now let's address the last one. Here we have to express all the trigonometric ratios, which are sine, cos, tan, secant, cosecant, and cotangent in terms of secant when A is an angle in the triangle. So let's address the simple ones where cos A is equal to 1 by secant A. So this is solved. Next, what we can try is, we know that cos square A plus sine square A is equal to 1. Now cos A can be written as secant, so let's change this first. So cos square A, so sine square A is equal to 1 minus cos square A. Now if we solve this, we can get 1 minus 1 by secant square A. Now if we solve for the common denominator, we will get secant square A minus 1 by secant square A. So this is nothing but sine square A. Now we only need the positive value because A is an angle in the triangle and it cannot be negative. So we will have square root of secant square A minus 1 by secant A. So we have solved for sine, cos and sine. So tan would be easy. Tan is equal to sine by cos, right? Now we just apply it here. What was sine? It is square root of secant square A minus 1 divided by secant A divided by cos. Cos is nothing but 1 by secant A. So the denominator get cancelled and we'll have square root of secant square A minus 1. So this is the value of tan. Now once we have tan, cotangent is easy. Cotangent of A is just 1 by tan of A. So we will write it as 1 by square root of secant square A minus 1. So what is remaining now? Oh, cosecant of A. So cosecant of A is 1 by sine A. So that is nothing but we just changed whatever we gained for sine. We inverse it. So we will have secant of A divided by square root of secant square A minus 1. So we have solved cos, tan, cot, cosecant and sine. So this is how we can express all the trigonometric ratios directed to one trigonometric ratio. Here in this case we are expressing everything using secant. Thank you for watching this video. Please share it with your friends. If you like the video, please subscribe to the channel as well. Thank you so much.